Philippe Rigaux. I'm with the CNAM Institute in France, in Paris, and I'm the coordinator of this project, CollabScore. Okay, so yeah, you can see the partnership. In short, we have 3 computer science labs, CNAM, University of Rennes, University of Lille. We have 1 musicology partner, which is Sorbonne University with the Erebus Lab. And we have 2 data providers, la Bibliothèque nationale de France, National Library of France, and Fondation Royaumont. Both data providers maintain very large digital libraries of scores. In particular, for the BNF, we have the Gallica digital library, which consists of millions of scores which have been scanned, which are static images of score, and they want to improve the situation. So I will go straight to the objectives of the project. We can identify 3 main objectives. The first one is, of course, the project is centered on optical music recognition with the goal of producing editable score in XML of high quality. High quality because, in particular, our musicology partner want to be able to produce, if possible, scientific editions of some corpuses. So even though they are ready to do some post-edition, they want to obtain, as a result of this, the whole process, something which is of high quality. So we are targeting the processing of images stored in the servers of BNF, like the Gallica, for instance. And we developed a new OMR system for that. Second objective is to improve, again, to improve the result of the OMR process with crowdsourcing campaigns. So we want to mobilize the groups of users in order to improve the result of the OMR, which is never perfect. And we have designed a set of interfaces to adjust or correct the element for which the OMR estimates that the recognition is uncertain or not of quality, high quality level. And finally, we have a third objective, which is to valorize the content of these library, digital libraries, with the capacity of with score following capacity, and in general with the ability to create what we call multimodal scores, where we will have a lot of several sources related to the same music work, which will be put together on links at a very fine granularity level. So I'm going to give some details, not too much, on each aspect. And I would like to say just before entering into details that this is the first presentation that we do of the project. Although we have been working for a few years on that, it's an ambitious project. So we are keen to receive, of course, feedback and comment from the community. All right. So regarding the first part, which is optical recognition, we use the DEMOS method. So I said that we developed a new system, this is not completely true because DEMOS is a method which has been designed by our partner from University of Rennes, ERISA, and it has been already used in the domain of text, and in particular in the domain of structured documents that contains forms and tables, for instance. So in our case, the method is applied to music notation. So the idea of the method, to be very, very quick, is to have low-level extractors which identify graphical objects of the score. And we also rely on a grammar which describes the structure of the music, the expected structure of the music score in terms of parts, voices, assignments of parts to staffs along the pages of the score. So this means that the output of the system is something which is structured. It's a hierarchical organization where each element is put as part of a voice, as part of a part, music part, and is put in a context where we have what we call reading context clé, time signature, and key signature. So to illustrate what we obtain, here is an illustration of the system where we identify the graphic elements with their, of course, bounding region, which can be used. I will come later to that. And you can see that we identify voices. We make best efforts to identify voices and also lyrics, and to relate lyrics to their notes, and so on and so forth. I will just show you one example of what we obtain on our corpus. So our partner from Eremus has defined a corpus, which is what we call the reference corpus. It's a collection of works by Saint-Saëns. So it's a single composer, so it's a bit restricted, but at the same time, we have a different kind of composition, different kind of works. We have melodies, we have quatuors, we have chamber music, maybe piano music as well. So we can see a melody. On the left, you have the Gallica image. On the right, we have the results that we obtained so far with the automatic OMR transcription. So we can see that the quality intuitively is high enough, but we have to evaluate that. Of course, we have to provide metrics. This is one of the main concerns that we have at the moment. All right. So I will now switch to the second objective, which is the objective of defining collaborative interfaces. We design with the partners campaigns in three phases, a sequence of phases. The first one is intended to check what we call the instrumentation, which means that we are going to look at the staffs of the score. The OMR system has assigned each staff to a part, but in many situations, it happens often that from one system to the other, the number of staffs is variable because we have a new instrument or a new singer who enters in the score or who left. And so we need to check that. We need to check that, and we do this as a first phase because if we make an error at this point, there is no chance to obtain a satisfying recognition of the score later. The second one is called reading context. And here we assume that the parts on the staff assignment is correct, and we are going to ask to the users to check the key signature and time signature. Because again, if there is an error there, there is no chance to correctly interpret the music object. And the phase 3 is music object. And there we can interact with a music object for which the system, the OMR system has reported some uncertainty and make some correction on the duration, alteration of I. Let me show you two screenshots because I don't have to make a demo. This is the first phase. So you can see that we present as default the analysis of the OMR system. So we correctly identified two parts, a piano and a singing part. The user will be able to tell if there is a mistake at some point and to correct the assignment. When we do this interaction, we obtain in the background what we call an editing operation, an operation which is recorded in the system and which can be integrated when we reapply the OMR process, which can be integrated in order to apply the edition and to improve the result of the OMR system. A second example, this one. So you can see that we have implemented interface components specific to let us change an element in case the element is erroneous. Here we are focused on the key, and we can change the number of flats or the number of sharps. We can also remove an element if it has been misinterpreted as part of the notation, whereas it's just a stain or something spurious. These interactions that we designed are limited. We don't implement a full editor. We really want to act on the elements supplied by the OMR system in order to improve its output. So we just focus on each element individually and make some correction if needed. Right. Finally, regarding the alignment, which is something I would say classical, but it's part of the project. We want to associate multimodal sources to the editable score, which is produced by the OMR system. We call this editable score a pivot because it's an XML. We have IDs for each element. So each element of the notation can be addressed. And we use this address to link fragments of multimedia sources with this element. For instance, in the case of an audio or video, it's a time frame. In the case of an image, it's a region. It's a case of a text, it's a section, and so on and so forth. And thanks to this central reference, we can put together at a fine level of granularity elements that come from very various sources. At the end, we are able to do something like the synchronization of sources. So you can see here an interface developed by our partner Rigaux, the Desran system, where we can show the Gallica image on the left, the Verovio image on the right, and we can choose on the bottom part a source, an audio file or a video file, and we have a synchronization which helps us to listen to the audio and see, of course, following the progression of the the notation on the images on both the image and the editable and the review representation. Okay, time to conclude. So the status of the project. We have been working on a lot of components. We have the corpus. We have some reference edition for the corpus. We have tested the system on this corpus. We have this collaborative platform, which is almost finished. So we plan to have a beta version early in 25. And we have those tools for sources synchronization, which is already available. So next step is a lot of improvements because we are far from perfect now. We are going to conduct a crowdsourcing campaign in May or April 25. You are all invited to participate if you are interested. So we are going to check the effectiveness, the capacity of the system to really make some improvements. And as we discussed since this morning, we need to evaluate our work. In particular, we need to evaluate our OMR production, both after the first phase, the automatic phase, and after the automatic phase extended, enriched with user interaction. So we really need metrics which are commonly accepted by the community in order to show what we are able to do, because I've seen that, for instance, there are some other systems which achieve quite nice results. We need to be able to compare with one another in order to see where we are strong and where we are weak. That's almost it. So again, I see that some of my partners are following the talk. We are keen really to collaborate and to have collaboration, comments, suggestions that come from you. For instance, you can participate to the campaign, but regarding the metrics, definitely there is a need for having something which will be estimated as reliable by the community. I just give you some links that can show some of the elements if we have some times. And thank you for listening. I'm glad to answer questions, if any.
Thank you very much, Philippe, for the fantastic presentation and project. Questions? Okay, Alex.
Hello. So the first question is on something that you mentioned briefly at the beginning, that your system estimates whether the results are of high or low quality. Did I understand correctly that? And if yes, how is the system kind of showing the confidence of its own result?
I think we have some extractors which provide an estimation, and I can see that my partners maybe would like to answer. Maybe Bertrand or Aurélie, you want to say how you do that?
Aurélie, maybe, or I can. Okay. So yeah, the idea that the system is first able to locate each element which have been recognized, and second, inside, because in the system we are modeling the organization, the syntactical organization according to the musical notation, we are able to detect some inconsistency. For example, we use in an orchestra score the correct alignments of notes and their duration globally. So we are able to both detect, for example, in a bar, if there is not the right number of beats in the bar, but we are also, with an orchestra score, able to locate inside the bar which note does not have the right duration because of the duration of the other notes. This is one example, but we can also detect when there is two changes at the key. For the key, for example, with the same key. So maybe there is one change which have been lost. And there is a lot of such checkings which have been done by the system and which are pointed out to the user with the interface of the collaborative correction. And the idea is to correct only those errors pointed out by the system, which avoid to proofread the whole score, which is very time consuming when you use a commercial OMR. And what we need to evaluate with the metric is does the remaining quality of the recognition after this proofread by the user is good enough to not need a global proofread.
Mm-hmm. And one small follow-up question, which also sounds really interesting to me, is you say the users are providing the feedback, they're correcting the clef or something, and then you incorporate this knowledge into the OMR system. How is that being done?
So there is a workflow that takes the image, does symbol recognition, produces a syntactic representation of the content of a page, and the system provides an ID for each element. So you can see, for instance, let's look at this example. This clay, this ID is an ID which is an ID provided by the OMR, which tells us that at this point, this is in fact coordinates. At this point, we have found a clay. And if the user has entered an edition that tells that this is not correctly, it's a F clay, for instance, we can register the edition and we overwrite the interpretation of the OMR with this edition. So we expect the user to provide a sequence, a list, a set of editions, and to apply this edition during the final step, which takes the structured output of the OMR and produces the music XML. That's how it works.
But just for me to understand it correctly, so basically inserting this information after the object detection and before it goes into your grammatical rules. Is that correct? Or
No,
somewhere else?
No, it's after the grammatical rules. We obtain this hierarchical description of the content of a page.
Okay.
And this
So you really kind of
on this description, each element has an ID, and then we overwrite the interpretation which has been made.
Okay.
We have in the system, in the demo system, which have been used on other kind of documents, we have this process of re-injecting interaction with the user, but for this project, for the moment, we work with a one-way flow where we just correct the structure which have been produced in Music XML.